In the first half of this lesson, we were talking about how you can measure angles in two different ways. You can measure them in degrees or you can measure them in radians. And we made the equivalence of, how you can measure a distance in either meters or in yards. It's two different ways to measure that same length. So radians and degrees give us two different ways that we can measure our angles. We talked about several different equivalencies yesterday, but probably the one that we'll go back to most often is the idea that 180 degrees is equal to pi radians. 180 degrees is equal to pi radians. So if you're trying to see the equivalent between meters and yards, it's really helpful to have a conversion formula. And that's what they give us on page 288, conversions between degrees and radians. Now, if we know that 180 is equal to pi, if I want to know just what 1 degree is equal to instead of 180 of them, I could divide both sides by 180 and I find out that 1 degree is equal to pi over 180 radians. So I could use that to convert from degrees to radians. I could use that same fact only a little differently. I could say if I know pi radians is equal to 180 degrees and I want to know what 1 radian is equal to, then go through and divide both sides of this by pi, and I'll have 1 radian is equal to 180 divided by pi degrees, and I'll use that to convert from radians to degrees. So let's say that we have 135 degrees and we want to convert that to radians. If I'm going to convert from degrees to radians, I'm going to use my conversion formula that 1 degree is pi over 180 radians. On my left-hand side, I don't have 1 degree. I have 135 of them. So I need to multiply this left side over here by 135 to get the number of degrees that I need. Of course, what I do to one side, I have to do to the other side. So if I multiply the left-hand side by 135, I'm going to need to multiply the right-hand side by 135. So now I have what I need on the left, 135 degrees, and on the right, I'm just going to simplify. 135 and 180 are both divisible by 45. So 45 goes into 135 3 times, and 45 goes into 180 4 times. So I would be left with pi times 3 in my numerator and 4 times 1 in my denominator. So that's going to give me 3 pi over 4. That would be the radian equivalent of 135 degrees. All right, what if I want to go the opposite way? What if I want to convert from radians back to degrees? Okay, well, I'm going to use my conversion formula that 1 radian is equal to 180 divided by pi degrees. I don't have 1 radian over here on the left. I have a negative pi over 2 of them. So let's multiply both sides by negative pi over 2. So now I have what I needed on the left-hand side, and I just need to simplify on the right-hand side. So on the right-hand side, the pi in my numerator and the pi in my denominator will cancel out. And then 180 divided by 2 would simplify down to 90 over 1. So in my numerator, I have 90 times negative 1, and in my denominator, I have 1 times 1. So that would give me a negative 90 degrees. Now there's a shortcut that I can use for converting between radians and degrees if I have a pi in my radian measure. So this only works if I have a pi in my radian measure. But since we know that pi radians is 180 degrees, if I take that same problem we just had a second ago and I replace the pi with 180 degrees, 180 divided by 2 is 90. So that's a little bit of a shortcut way that I could convert from radians to degrees. Okay, well then why do I need the conversion formula? That's so much faster and easier because that only works if I have a pi. If I get down here in just a second and it says convert 2 radians to degrees, I don't have a pi to put 180 degrees in for. So I have to have the conversion formula for that. All right, let's look at another one. Negative 270 degrees is equal to blank radians. So I've got my conversion formula down here. What do I need to do? What do I need to multiply my conversion formula by? Negative 270, right. I have 1 degree over here. I need a negative 270 of them. And of course, what I do to one side, I do to the other side. So now my left side is set. I've got my negative 270 degrees. And I'm just going to simplify my right side. So 270 over 180 reduces to 3 halves. So in my numerator, I've got negative 3 times pi. And in my denominator, I've got 2 times 1. So negative 3 pi over 2. All right, if I want to convert from radians to degrees, and I can't use my little shortcut because I don't have a pi to put 180 in for, so I am going to have to use my conversion formula. So if 1 radian is equal to 180 over pi degrees, what do I need to do to that formula? Multiply it by 2. Perfect. So I'm going to multiply both sides of that by 2. On my left-hand side, then, I would have my 2 radians that I need. And over here, nothing will simplify. So just 180 times 2 is 360, and pi in the denominator, so 360 over pi. If you literally wanted a number of degrees, you could throw into your calculator 360 divided by pi, 360 divided by 3.14, and you would get an actual number of degrees. It's a little bit less than 120, which makes sense because we know that 1 radian is around 57 degrees. So. All right, the next formula that they give me is over on the top of page 289. It's not actually in a box or anything like that. It's just in italics there on the top of the page. And it's a formula that gives me a way to relate the arc length, the radius, and the central angle when it's in radians. You might remember the actual definition we used for a radian was that your central angle will be 1 radian if your arc length and your radius have the same length or the same dimension. So if my radius is 5 and my arc length is 5, then my central angle is 1 radian. So we can see how if these were the same, that would give me 1 for my radian. That makes sense. That formula can be turned around to solve for any one of those missing pieces. For instance, here we're solving for the central angle, but what if I wanted to solve for S? How would I solve this equation for S? Multiply it by R. So if I multiply both sides by R, then I have a formula for my arc length. S is equal to R times theta. If S equals R times theta and I'm trying to get R by itself, what would I do? Yeah, I'm going to go through, once I've multiplied by R to get to this point, then I'm going to divide by theta. So if I divide by theta, I would have R is equal to S divided by theta. So it's the same formula. We could just turn it around 3 different ways to solve for whatever it is we need to find. But the key here is that theta has to be in radians. So for example 5, they tell me a circle has a radius of 4. Okay, so radius is 4. Find the length of the arc, so that means I'm going to be looking for S, intercepted by a central angle of 240 degrees. Okay, so if I'm looking for S, I'm going to use this formula right here, that S is equal to R times theta. What was R? 4. And theta was 240, but the problem with that is, remember we said that theta must be in radians, and they gave me theta in degrees. So I'm going to have to convert from degrees to radians, exact same thing as we were doing up here just a few moments ago, right? So let's grab our conversion formula. 1 degree is equal to pi over 180 radians. What do I need to multiply that conversion formula by? 240, perfect. So let's multiply both sides by 240. I'll have what I need on the left-hand side, and then I just need to simplify on the right-hand side. 180 and 240, each divisible by 60. So 180 divided by 60 is 3. 240 divided by 60 is 4. So I'll have 4 times pi in my numerator and 3 times 1 in my denominator. So 240 in degrees is 4 pi over 3 in radians. So we'll come over here and replace theta with 4 pi over 3. Alright, so now we can finish our problem because it was S is equal to R times theta. We had R, now we've got theta now that it's in radians. So what are we going to get for our arc length? Yes, 16 pi over 3. And if they wanted a decimal for that, we could, 16 times 3.14 divided by 3 and actually come up with a specific length if they wanted one. Okay?